Hello students, welcome to this 25th lecture session of Database Management Systems. In this session, we continue with our discussion on XML technology. We will see how to store. In the previous session, we understood what is XML and what are the various features of XML, what is DTD and what is XML schema, and then how we can describe the structure of an XML document. In this session, since we understood that XML documents can be treated as databases, since we store a lot of data in XML documents and are exchanged across the businesses, we now see how data can be stored in XML and how to store data, XML data in persistently, and how do we query XML documents or XML data, and the XML query languages like XPath, the popular ones, XPath and then XQuery. How do we use XPath and XQuery to extract or retrieve data from the XML documents? We will also look at very important applications of XML technology. Now first let us understand how I can persistently store XML data. There exist different approaches for storing XML data. The first one is using a database management system to store the document as text. That means, for instance, if you take relational database management systems like Oracle, where an entire document can be stored as a binary large object along with its text. Similar kind of concept can be used for XML documents as well. That means I don't split the XML documents into bits and pieces, rather I take the entire XML document and store it as a text under a given attribute or the field in a table. That is the first way of doing it. Next thing is, if you wanted to have a better structuring and then dismantle the XML document into bits and pieces and then put them under appropriate fields or columns in relational databases, that can be done. We can use a relational database management system and store the document contents as data elements. That means I take the XML document, I dismantle that into different bits and pieces based on their elements, and the values for various elements can be inserted or stored under the fields or columns in a table. That means there should be a mechanism to structure a relation or a table which can store the details or the particulars or data of a given XML document that is required. Once you have that kind of structuring, that is mapping from XML to a relational database structures, then it is easy to dismantle the XML document. And how do we dismantle that? By using some parsers, XML parsers, we can collect the individual pieces of XML document and I can keep putting them or inserting them into appropriate columns for different rows in tables. That is the second approach. The third approach is, in both the cases, what happens is, in the first approach where the entire document is stored as a text, the entire document is treated as a text, okay, one single file, and there is no much about the hierarchical structure of the XML document, and I can say that rather it is mostly in unstructured way. I am going to store it in unstructured way. And if I take the second approach, that is putting the various parts of XML document or elements of XML document into tables, that is, I may lose. Here in this case, what I am doing, I am chopping down, I am dismantling XML document into bits and pieces. That means the very nature, hierarchical nature of the XML document is lost. And when you store the data in tables, the XML data in tables under various fields and then various rows, then if you wanted to again construct the XML document back from this data contained in the table, then it is known as XML publishing. That is a complex task, because while doing this, while storing the XML data into tables, you entirely lost the hierarchical structure of the XML data. That is the biggest problem. The third approach is without losing this hierarchical nature of the XML document, and depending on the requirement, I can take, because I understand that it is clear that the XML data can be represented as a tree in a hierarchical way. That means I can take the various subtrees of the document and store them in some native storage in the native form, meaning that the tree structure is maintained and subparts of the XML document. What is the subpart of a tree? It is also another subtree. So similarly, we collect the individual subtrees of the XML document, and while maintaining the hierarchical structure of the documents or the subtrees, we store them in some databases. And that kind of databases are known as native XML databases. For example, Tamino, Berkeley DB, and which is now taken over by Oracle. You can store XML documents in its native form, and then you can use XPath or XQuery expressions to retrieve data from these databases. The first approach is storing them as simple text under binary large object or the text fields, or otherwise dismantling it and storing it in the tables in relational database management systems, or storing XML documents in native form. These are the three approaches available. Now, after understanding how I can store the data, XML data in the databases, now let us understand what are the various querying techniques, querying languages for extracting or retrieving XML data from documents. First is XPath, which stands for XML Path Language, and the XPath provides a syntax for locating specific parts of an XML document effectively and then efficiently. In XPath, an XML document is viewed conceptually as a tree in which each part of the document is represented as a node. Okay, it is treated as a tree, and each part is a node. And what are the various symbols that are used in XPath expressions? The dot symbol denotes the current node, and an XPath expression is more like the expressions we use to represent the hierarchical paths in file structures. Okay, so if I say this, what is the meaning of this? And then if I say that my.doc, what is the meaning? In the current directory, there is a subdirectory called as X, there is a subdirectory under that called as Y, and in that subdirectory there exists a my.doc file. So similar kind of expressions we use to represent or to address the locations of the XML documents. The dot is used to denote the current node, and the forward slash denotes the children of current node. A slash, this symbol is going to connect the parent and child. So if I use this here, this is the parent, and immediately Y is the child of X. And two forward slashes denote the descendants of a current node, and then the @ symbol represent attribute of a current node, and the square brackets where we can enclose the Boolean expression serves as predicate for the given step. And each one of these, each part of this XPath expression is known as a step. So at a given step, if you wanted to attach some predicate or some condition where the step is validated, or a given element which is addressed by that particular step is validated, I can include some Boolean expression which will be evaluated to true or false. Okay, and such kind of Boolean expressions should be enclosed in square brackets. And within the square bracket, as a predicate, if it consists an integer, it serves to select the element with the given ordinal number from list of elements available. So if I say that this is the under the root element, if I have book element, and under this if I have author, and if I say 3 here, instead of the Boolean expression, if I put an integer value here, it indicates that under the root element there is a book element. Under the book element there are many author elements. For each book, pick the third author element and display it in the result. So I am talking about the third author element under book, which is under root element. The following XPath expression selects all the name elements of all the student elements of the department element. So if you look at this, department is the root, under that you have a student element, and this indicates name is under the student element. Student is under depart element. And this XPath expression actually selects all the name elements which is part of student element, which are part of department element. We can also use wildcards, that is the star, used to select unknown XML documents or elements, XML elements. If you look at this XPath expression, under department, under student, star, meaning that give me all the elements. Star is a wildcard, and then it indicates all the elements which are children of student element, which is under department, should be displayed. That is the meaning. And similarly, if I use /star, this indicates it selects all the elements of the given documents which are under the root. So the all descendants which are under the root means what? The entire document is selected for the display. If you take this example XML document, you have a bank element, and under the bank you have account elements, and then you have customer elements. Under account element, it has an attribute called as account number and attribute called as owner, and it has branch element and balance element. Under the customer, you have customer ID as the attribute and the account number as the attribute, and you have customer name, and you have street, customer street, and then customer city as the sub elements. And how many account elements are there under bank element? There can be any number. Let us assume that one or more. And customer elements, one or more are possible. And every account has exactly one account number attribute, one owner attribute, and one branch name, and one balance. Similarly, the customer has one customer ID attribute, one account attribute, and then one customer name, one street, and then one city. Given this kind of XML document with the given structure, let us try to formulate some XPath expressions to retrieve the required data. If I wanted to return all the name elements or the names of the customers, all customers, then how do I write XML XPath expression? It is like this. Under the root, bank is the root element, customer is under bank, and a name. That means I am talking about all the name elements of customers. And when I say this, what is the result? The result is going to be the name elements which are under customer. Name, first customer Raju, name, and second customer name, that is along with the start tag and the end tag, the names of the customers will be displayed, Mohan, and it is the end tag, okay, name. And similarly, the third customer, it will display this. That means when I don't specify anything and then leave it like this, it indicates that along with the tags of the elements, display the names of the customers in the result. If I don't want to get these tags, start and end tag, rather I would just want only the text associated with this name tag or the element, then I can use this syntax. Go to the name element of customers, all customers, and pick only the text. Then in that case, it will display only Raju, Mohan, John, only the text associated with the name element without the tags. And if I wanted to get the account elements where the balance of the account is greater than $400 or rupees, then I can use this kind of syntax. You hear. Here it is under the root. I have bank element. Under the bank, I have account elements. I wanted to display account elements, but I don't need all account elements. I want only those accounts where the balance, which is sub-element of account, the value is greater than 400. So for this step, that is for the account, I am writing something in square brackets. What does it indicate? I am applying a predicate there. What is that? The balance element, which is under account element, the value should be greater than 400. Only such account element should be displayed in the result. Okay. The next one, if I wanted to get the account number of those accounts where the balance is greater than 400 rupees, I can use this syntax. Under the bank, go to account elements, check whether the balance is greater than 400 or not. Since it is a predicate, it is enclosed in the square bracket. And next, in the next step, go to the account number attribute. At the rate symbol is used to address what? The attribute of a given element. So at the rate account number, since it is following this, so it is in the next step, it is followed by account. So I am picking up the account number attribute value for the accounts whose balance is greater than 400 and display that in the result. Okay, now if I wanted to get, and we can also use the aggregate operations like average, count, min, max, all these things are possible in the standards of XPath. Let us see how to get the account elements where the number of customers is more than 2. And if you look at the structure of this XML document, it is understood that an account can have any number of customers. An account can have any number of owners. Okay, let us assume that an account, if you look at this account, the owners, there can be any number of owners. So I wanted to get the accounts whose number of customers is greater than 2. Now the other query language is XQuery language, which is more sophisticated than XPath, and it has been proposed as standard for querying XML data. It uses SQL-like syntax. In SQL, what is standard? You use select, from, where clauses. So similarly, here also we use for, let, where, return clauses to express our queries. So if you look at in short, if you collect all these first letters FLWR, and in short it is known as flower expressions. The expressions written in XQuery language are understood to be flower expressions. Okay, and what F stands for, L stands for let, where W stands for where clause, R stands for return clause. The for clause, what it does? It generates bindings for variables. The let clause binds one or more variables to the result of one or more expressions, XPath expressions. And where clause, binding tuples generated by the for let are subject to filtering by the where clause. And return clause generates the output of the flower expression. Okay, and here these XQuery language syntax or the expressions, they internally use XPath expressions. And let us have a look at some example. I have a XML document with the following structure. Bibliography is the root element. It contains one or more book elements. It contains publisher as the sub-element, title as the sub-element, and a book contains one or more authors. It contains price and it contains year. Okay, and the XML document name is bibliography.xml. Okay, and let us assume I have given you the structure. Let us assume some scenario where you will have valid data for the document. That means, and if you look at the bibliography root element, you will have a book element here, and book element will contain publisher and it will contain title, something like this. So if you assume that kind of document, then if I wanted to list the titles of books published by the publisher PHI in the year 1988, how can I write an XQuery expression? The first is for class, $B, which is known as a path variable. This is the standard syntax. In document, what is the document? Bibliography.xml. This indicates that anywhere in the document, // is descendants of the root node. So book is a descendant of the root node, and then I collect all the book elements and then I bind it to $B. So if there are 3 books, DBMS is one book, OS is another book, and then networks is another book. If there are 3 book elements, all these 3 book elements as a collection are bound to the $B, and it retrieves the collection, and then each one of these elements is assigned to $B in one iteration. So in for class, I have collected all book elements, and then each time in each iteration of execution of this query, one element is attached to, assigned to this $b, which is known as the path variable. Okay. In the first iteration, $b refers to DBMS book. Okay. And $b.publisher, for the DBMS book, who is the publisher? If it is PHI, I am writing this in where clause. If $b.publisher / publisher is PHI and $b/year is 1988, then because these two conditions are satisfied, then the element, book element which is specified by this $b qualifies to be displayed in the result. So for such $b, I display the title. If I don't specify text, what does it mean? It returns even the tag names of for the title element under the book. So for the first iteration, $b indicates what? DBMS. So if these two are satisfied, the DBMS book details title is displayed in the result. In the next, it will go for the next iteration. In the next iteration, $b is assigned with the OS book element. Again, for that book, it will check whether the publisher is PHI or not and the year is 1988 or not. If it is true, for $b, it will pick up the next element, that is the title element, and then display it in the result. If these, at least one of these is false, then that element, book element, is not displayed in the result. Of course, in this example, I have not used the let clause. Okay, and we will see how we can use let clause in the next example. So that's why here the $b is known as the path expression, and this is the path. This is actually an XPath. If I say document this, it refers to the root node, and the root node descendant book means at anywhere down the line under the root node, if there is a book element, I will pick up all such book elements and then assign that to in each iteration, one of the elements of this collection or list is assigned to $b. And on that $b book element, I will conduct this test. If it qualifies or passes the test, and I will pick up this kind of element from $b and then display it in the result. And I go with the next iteration. In the next iteration, the next element in the list is assigned to $b, and I will do the same thing for the second element as well. For all the elements in the list, I will do this exercise, and whatever is the final result, that is displayed to the user. Okay, I wanted to list each publisher and average price of its books. I am using the for class. Here $p is the path variable. Since it is a variable, I can use any name, and normally it is customary to represent a path variable starting with $, and here you can write whatever identifier I want. There is no problem. And for $p in the distinct document, this is the root node, and I collect all the publishers. This is what this denotes, the descendants of the root node. So anywhere in the structure, if you look at the structure, pick up all the publishers and then pick up the distinct publishers. This is what? It is the operation on the collection. So it will give me the distinct publishers. Some cases what happens? Multiple books may be published by same publisher. I want only the distinct publishers. So I use this distinct operation function to pick up only the distinct ones and then eliminate duplicates. And this indicates the root element. Under the root, I will pick up somewhere down the line in the structure hierarchy, I have publisher elements. I will pick up all such publisher elements, and let us assume that first one is PHI and the second one is McGraw-Hill's and third one is Wheely, something like this. So all such will be available in the collection. In the first iteration, $p is assigned with the PHI. Let us assume that way. And now in let clause, what I am doing? $a, that is another path variable. What I am doing? I am again going to the root node. I am picking up the book element and I am checking whether the book element's publisher is $p or not. What is there in the $p? What is stored in $p in the first iteration? It is PHI. That means I am invariably picking up all the book elements where the publisher element value is PHI, and only for such books I am picking up the price, and for all such books I will collect the price and then compute the average and then store it in $a. Now $a contains the average price value for all the books published by PHI. Now in the return clause, what I do, and I am specifying the publisher tag and name $P text, that is the publisher's name, only the text, and I can specify the tags. In the return class, I can specify my own tags, how to format the result for the display purpose. Okay, and the first statement says that the name, I will pick up the text content of the $P. In the first iteration, if PHI satisfies and this, then I will pick up the $P, that is a publisher, and his average price is $A. $A contains what? For the PHI, what is the average? That I am printing here. Next, I will go to the next iteration. Next iteration, the $P is assigned with McGraw-Hill's publisher, and again I will compute all the prices for all the books that are published by McGraw-Hill's, and then I will compute the average, store it in $A. In the second iteration, $A value stores the average price for all the books that are published by the second element, that is McGraw-Hill's. And for such, if it is for such $P, I will pick up the publisher name, print it in the result. I will pick up the average which is stored in $A and print it in the result. And go to the third iteration, do the same thing for other elements as well. So this is how it works. And then here, of course, I don't use the where clause. Applying a condition is not mandatory, and you having a let clause is also not mandatory. Depending on the situation, you can use where and then let clauses. And the return clause, we specify what is to be returned as a result of the query to the end user. And we understood what are the query languages, popular query languages for XML documents. And if we look at the applications of XML, it is enormous. I cannot list the applications of XML. The current day world, that is IT world, computer science, the XML technology has become de facto standard for representing or exchanging data on the web. And then apart from that, many applications use this XML technology, and by default all platforms, they support XML documents, XML parsing and XML processing. That is the advantage. And let me name few areas where the XML is predominantly used, and of course it is unlimited. Okay, the first one is domain specific markup languages can be generated or built from the XML documents, XML technology. XML can be seen as a meta language. That means a language for creating other markup languages. Many domain specific markup languages are developed to standardize data exchange in that particular domain. For example, mathematical markup language, which is known as MathML, and which is used to exchange the mathematical equations and expressions, can be used in this domain. And similarly, we have chemical markup languages, where the markup language used to exchange the chemical equations, formulae, etc. And geographic markup languages, GML, which is a standard way of exchanging or sharing data pertaining to geographical information. And these are a few application markup languages which are domain specific. Similarly, if a new requirement comes up and if we wanted to create our own markup language for a given domain, we can always do that and use the XML technology and then create a new markup language for whatever domain we want to generate or build these markup languages. The second application is data integration systems. Data integration is the problem of combining data residing at different sources and providing the user with a unified view of this data. So in this case, what happens is nowadays, owing to the technology advancements, and data is not residing at one place. Data of an organization or a domain or a particular used by applications is spread across multiple locations, and at each location the data can be stored in different models. One location it can be stored in XML model, another location it could be relational data model, in some other location it could be object model, so on and so forth. And as far as the end user is concerned, since all this data stored at multiple locations in heterogeneous forms and they are all related, as far as the end user is concerned, it is desirable to provide an unified view to the end user. In that case, we should create an unified view for the end user, where this unified view is going to represent the structure of the data that is contained at different locations in different formats, and then as far as the end user is concerned, it is only one single format and then one single location. That is, the transparency is there, location transparency, and then format or modeling transparency is there, and the end user will think that data is available at only one location in only one format. And now if we, based on this unified specification or unified model description, he can formulate his queries and then submit the queries to this integrated system. This is known as the integration system. That is, this system is integrating the data that is contained or stored at different locations in different formats and providing a unified view to the end user, so as to make user possible to formulate queries and then submit queries to this mediator system or this integration system, so that he can extract the data from different sources in a transparent way, easy way. Okay, so there should be some mechanism to describe the structure of the data in a unified way, which is contained or stored at different locations. And it is understood that, it is observed that XML format is the best suited format to represent the data which is available in different formats. Okay, that is, if you take object format, object databases, the structure of the database can be represented in XML format. If you take relational database, yes, I can use XML format to represent the structure. Similarly, it is easy to represent the structure of any data model in XML format. Hence, it has become a standard to represent the unified view of the integration system database or the structure of the integrated system using XML format. On this XML format, since it is being viewed by an end user in XML format, and it is quite obvious that end user can formulate and then submit queries in some XML query language. And then, because the system, this integration system does not hold any data, actual data is available at different locations in different formats, then this integration system should understand the query submitted by the end user, and which is based on the unified view provided to the end user. Then it should dismantle that query and then create subqueries and then appropriately post them or send them to the appropriate locations for the purpose of execution. And that XML query submitted by end user is now converted into relational SQL query and then sent to the first location, object query and then sent to the second location where the data is stored in object format, so on and so forth. And since these individual locations can understand the format of the query, because the integrated system has taken care or put some effort to convert the user submitted queries and rewrite them into the location specific database understandable form and submitted that to the individual databases, they can execute the queries and then submit the result back to the integration system. Now again, the integration system will combine all these results and give it to the end user. Okay, so what is the use of XML technology here? Because it is observed that in such kind of integration systems, specifying or describing the unified view or unified format of the data stored at the different locations becomes very, very easy and straightforward. If I use XML format, I use XML format or XML structure to represent the unified views. And of course, since it is in XML format, and the end users can submit their queries in XML query languages. So that is how this technology, XML technology, is used in integration systems. Okay, and a large scale websites which serve information from multiple sources in different data models can be viewed as, can definitely use this kind of integration systems, data integration system technology, and in such situations we use XML formats. Then the third one is data exchange between the applications. Presently almost all software and then applications have capabilities to represent and then interpret data in XML format, and all platforms, they support XML data and then XML parsing, processing. XML models capability to capture any business data is the key motivation behind the SOAP. Okay, and SOAP technology, where it is simple object access protocol. And the web services, they provide services to the various clients, and the client can submit his query using a SOAP message, and this SOAP message can be understood by this web service, and it can open that SOAP message and then understand what is the request submitted by the client. It can execute that service or function, and again retrieve the result for that particular function or the service, and then wrap that result of that functionality in another SOAP message and then send it back to the client. So that's why exchanging messages between the client and server in service oriented softwares, it is the SOAP technology is used. Okay, and in SOAP the XML format is used for exchanging information between the systems. And these are the very dominant uses of XML technology. I already told that I have listed very limited number of ones, and actually the use of XML in the current day IT world is unlimited. Okay, every application uses XML technology in one form or the other. Okay, it is almost like that. So that is the significance of XML technology in the current day scenario. In this session, we understood how to store XML data, what are the various approaches, how to store XML data using DBMS, standard existing database management systems, and then how to store XML data in native forms. And once we store the XML data, how can we retrieve the XML data from the databases? That is, we looked at the query languages for XML data, that is XPath expressions and XQuery expressions. And XQuery is more sophisticated than XPath. XPath, it facilitates addressing locations in XML documents, and then XPath internally uses XPath expressions. XQuery uses XPath expressions, and it is more sophisticated than XPath. And XQuery has become the current day standard for querying XML documents, and it uses the flower expressions for let, where, return clauses, like what we do in case of SQL. Select, from, where clauses we use in SQL. Similarly, here we use flower expressions. And at the end, we have also seen the dominant, important, popular applications of XML technology. Thank you very much.